Okay, let's now look at question 4. Okay, question 4 says that a bullet of mass 0.08 kg moves with a speed of 4 times 10 to the power 2 meter per second, hits a heavy target. Okay, the bullet stops after penetrating 0.15 meters into the target. What is the average resisting force of the wall on the bullet? So in this type of question, it's good to sketch a diagram, a simple diagram. So in this case, if I say that this is my target board, okay, this is my target board. Okay, and in this case, this is my bullet. Okay, and this bullet originally is maybe at a certain distance away, maybe somewhere over here. Okay, and it's going to move towards the target board. So in this case, when it start moving, okay, it will hit the board, and it will, as what was mentioned, it will penetrate 0.15 meters. So in this case, if this is the original size, so maybe it might penetrate up to over here. Okay, just do a simple estimation. Okay, and the penetration over here is 0.15 meters. So 0.15 meters, you have to be very careful. It's between the inside of the board to the edge of the bullet. So this is what it's talking about. Okay, so originally it has a speed. So the speed in this case, we use the simple v. So v is equal to 4 times 10 to the power by 2 meter per second. Okay, and the mass is given. The mass is 0.08 kg. Okay, so in this case, the speed v is given, the mass is given, and this penetrated, this actually is a distance. So this is actually my d. Okay, so what kind of equation can we form? So in this case, it's talking about conservation energy. So an object has speed, you know that it possesses k. So in this question, the starting energy has to be kinetic energy. Okay, so it's half mv squared. Okay, so this is the starting energy. And when it starts to penetrate, as what was mentioned, there's actually a resistive force inside the board that opposes the motion. So in this case, the resistive force is actually trying to resist the motion. So this is my F. Okay, and in this case, it's trying to do work against the motion. So the work done. So this is a work done. So this is my resistive force F. That's my distance move. So you notice there are actually two types of forces in play. One is the original Ke, and the other force is due to the work done against the friction. So we can form an equation now, which is my starting energy, which is Ke half mv squared, which is actually equal to F times D. So to solve this question, we have to work with this formula. So how do we apply this formula to solve the question? So we just plug in the numbers. So it's half times 0.08 v squared. Must be very careful here, v squared. So I must open bracket 4 times 10 to the power 2, and then we must remember the square is equal to my resistive force F, which is the unknown, times my distance move, so it's 0.15. So I just do some calculation, okay, and I have gotten that my F, I just press my calculator. My final answer for F is 4.27 times 10 to the power 4 Newton. So if I round up, the answer will be 4.3 times 10 to the power of 4 Newton. So in this case, the answer will be B.